Hello, welcome. This is a little series where we're gonna make a automatic watering device for herbs that you can buy in the supermarket. And I love to use fresh herbs when I'm cooking spaghetti or whatever kind of dish. It's always nice to just like. And therefore I buy a lot of these fresh herbs. And often I don't use the whole herb, so there's some of it left for another time. And then I forget to water the herb. So then the herb will become like this little one I have here. And you can see that it's on the point of dying because I didn't water it for 2 days. And if I forget to water it maybe 2 days more, it will be dead. And often I end up with these dead herbs and I don't have any fresh herbs because I forget to water the plant. And therefore I was wondering what can I do about this problem. And then I thought I will make an automatic watering device. So I have these, I went to eBay or AliExpress, actually I think it was, and I bought some electronic devices. And I bought these, where we have an Arduino Pro Mini, and it's just because of the small size, and it's very cheap. That's the reason I bought this one. And then I have a relay that can take higher current through than the Arduino can handle. And I have a moisture sensor. And for the moisture sensor, there's this kind of fork with. And here's a fresh one. You can see the difference. So this is bad quality. So I need to make one of these at some point out of like stainless steel or something. So, and then the way it works is we have the fork, which is put under a cloth like this, or all the way in, and then this one is just like there's like a resistance between these two forks, and that changes on how wet it is. So if it's more wet, there's less resistance through, and then this small chip here can sense that. And then it can either send in an analog value or it can send in a digital value. And for this purpose, we will use an analog value. So if there's a lot of resistance here, it's going to turn in a low value. And if it has a high resistance, if it has a high resistance, it's going to turn in a low value. And if it has a low resistance, it's going to turn in a high value to the Arduino, to the brain, this one. And so it's actually why I point this way. So we have this one in the plant. This thing interprets the resistance between this one, and you can either put this to a digital pin where it just turns on a certain value, which you've put in on the screw here, which is a small screw, or you can turn in an analog value, and then the Arduino interprets the analog value. So then when the Arduino gets the information from the moisture sensor, the Arduino will, at some point, there will be too dry on this cloth because the plant takes in the water and because just evaporation to the environment. And at that point, the plant is going to need some water. So then the Arduino is going to send out a digital on and off signal out to this relay, which there's these pins connected to. And the relay will turn on, and then I can draw high current through the relay to a pump, maybe like this, or some other pump. I actually used another pump because this one put out too much water for this small plant. So basically, we have these devices which we connect, and we put them into the plant and power it up, and then we don't need to worry about watering the herbs, and then we have always fresh herbs. And that is so I soldered these things together, and there will be a more separate video on how to do that if you're not interested in that kind of thing. And I soldered it all together, and I turned up with this, or ended up with this. And as you can, as you can see, we have at the bottom the moisture sensor, and then we have the Arduino Pro Mini, which has been soldered some wires into, and there's also power connected to it here, which goes out to this one. And then we have this relay, and it's another relay than this one, but it does the same thing basically. And on top we have a peristatic pump, which pumps a smaller amount of water than this one, which pumps a big amount of water. And this is perfect for small plants like this, so we don't get water all over the place. And so you take this one, and then the first trial I had with this one, I just put in, wait a minute. I just put in this kind of power supply, which I then soldered onto this one, and then that way it should power everything, the whole device, both the pump and this small Arduino here. And when I looked in the data sheet, this Arduino was rated to handle 12 volt, and then if I didn't connect devices that draw more current than a certain amount, it should be okay for this kind of supply, which is 20 watts max. But then I put in this 12 volt on this China board, and then I was like, then I could feel on it, and it was becoming really hot, so I actually burned my fingers on the small, I don't know, it's a MOSFET transistor or something. And it was so hot that I was worried about burning the whole board. So I had to take it out of the power supply, and then I was like, okay, it doesn't work. And then I was thinking, okay, what can I do? So I thought, okay, it needs less voltage. So I took this, and this one is a USB to serial connector that you use for coding the Arduino Mini. And it can also just be used as a power supply for Arduino. So here you have a 3.3 volt and a ground. So it only uses 3.3 volt and the ground. So now it doesn't become so hot, but it still becomes a little hot. So I put it on, the whole idea with this installation. So I put it on a heatsink to take out most of the heat from this Arduino. And I put in some like heat tape that can transfer the heat but not the electricity. And then it can work on a longer scale, a week, a month, without burning down. So you take this one plug here, you can see this is for the water to the plant. So we can plug that in there, and we have the water. There's still some water left in this. And here we have electricity. So now we will try the whole system up and see if we can water the plant with this small robot that I've made. And it's all just glued together with actually the double-sided tape So it's really easy to make, and I think if I dropped it on the floor, it would also break. And there's a lot of wires out. So this is called a rat's nest. Actually, all these small wires that comes out, they call that a rat's nest. And the rat's nest is strong with this one, I think. So normally you would make just one. It's called a printed circuit board of a PCB. That where it has all these functions on one board. But this is like a prototyping thing. So I didn't use all the time on. But maybe you can do another and you can make your own. If you want to do that, go ahead. So now we'll rig this up and try to make it run, and we'll see how it works.